Hey guys, this is Junaid here from K21 Academy and I welcome you all to this interesting session where we're going to see Python for data science. So without any further ado, let me quickly walk you through today's agenda. In this session, we are going to see what is data science and why do we need it. Following that, we're going to have a look at various languages that support data science. Moving ahead, we'll see one particular language, that is Python for data science, like the reasons why you should use Python for data science. Then we are going to, as we move ahead, we are going to see the various tools and libraries that Python supports for data science operations. Finally, we are going to have a look into a workflow of data science, and in accordance to that, we are going to see how we can predict California house prices using data science. So this is all for today's agenda. So before we begin, please do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're interested in looking out for a free course, K21 Academy, please do check out the link given in the description box below. Alright then guys, so let us now start off by understanding what is data science and why do we need it. Okay, so what is data science, right? Like in general, what do you think data science is? So it has two things here. It has a data and science. If you want a book's definition, right, you can see it over here, but let me give you a brief understanding of what data science is. Well, when you talk about data science here, you're going to deal with prehistoric data. Okay, and what I mean with this prehistoric data is that, let's say you have 100 GB of data wherein you have independent and dependent parameters. So what is this independent parameters? Independent parameters usually refers to the different features, and the dependent parameter is basically an output. If you want me to give you an example, let's say you want to predict the price of a car. So here the independent parameters would be the age of a car, the fuel type, whether it's running on what type of gas, that is diesel, or is it running on petrol, or whatever it is. Apart from that, number of people who can sit here, the number of doors. All of these are the features that describe a car, right? So that's why these features are called as independent features. The dependent feature is what we said as price over here. So based on these independent features, we would have a general intuition, right? Or let's say real-time example. Let's say if the car is old, the value of the car is less. If the car is newer and if it has two doors, usually it's referred to as sports car, the price would be higher, right? So that is what is called as dependent parameters. So dependent parameters are dependent on the independent ones. So based on these dependent and independent parameters, we create something called as mathematical models. Usually these mathematical models are statistical models. And based on the statistical model, any new data that you provide, it gives you a prediction, something which is similar to that of a human being. So this is why data science is important. So where do we use such technologies, right? So we use data science in many things, such as banking industry, for predicting house prices. In order to help real estate, we use data science there as well. I'm sure another question that might pop into your head, like, why do I need data science? Like, if data science is all about decision making, why do I need data science, right? Like, I can use if else condition, I can use, various looping conditions and all of that. So why do I need to have data science? Well, to make your answer simple, looping statements or the condition statements are computationally very expensive, especially when you're dealing with huge amount of data set. Okay, so if you can create a statistical model, you will not only be able to enhance the efficiency of your system, but also get a prediction which is kind of similar to that of a human intuition. Therefore data science is important. Apart from that, with data science we can solve complex problem with the help of mathematical equations. Alright then guys, moving on to the next question. What are the different types of languages that you can work with data science? People usually have this conception that there are only two languages for this using data science that you can do. But data science being a booming technology, every language has some of the other support for it. So let's see some of the languages here. Some of the languages can be like C++, then we have C programming, Java, Python, JavaScript, R, and MATLAB. Although MATLAB is kind of used when you're into a research domain, yeah, where you're working on image processing or language processing. This is why you use MATLAB. The one that is popular in demand are Python and R. Like if you're dealing with a tabular data, people most of the time use Python and R. If you are working with the web development as well and you want to integrate data science project, there's nothing better than Java and JavaScript. C and C++ is usually used, especially if you have to integrate machine learning and deep learning with your game development and all of that, virtual reality. This is where you use C and C++. So as I've mentioned, a couple of languages, but why most of the time people use Python for data science, right? Like why Python? Like what makes Python so different from other programming language? There are a couple of reasons for that. One being that the Python syntax is pretty simple. Okay. And as this Python syntax is pretty simple, what happens is it's easier for people to learn. So it won't take rocket science to understand how Python works. So it's the workflow of it, the way Python libraries are there, how to import them and how to utilize them. It's kind of simple and similar to use when you're trying to use Python. The next reason is that scalability. Let's say you're working on a huge project. The Python is the over time it has developed so much that you can not only work for a small one, you can also work on a bigger application. Like you can say Django if you want to develop or deploy your application. Or you have various APIs that will help you scale your application. So scalability is another factor that people use Python for data science. Then we have various libraries or APIs that you would say, be it for something as simple as dealing with your tabular data, you have NumPy, but if you want to go something as complex as computer vision, we have Keras and TensorFlow. The next important thing why you should consider Python for data science is that it has a very huge community. Let's say you are facing an issue over here. Let's say you have some doubts. All you have to do is just go down to Stack Overflow or some lot of groups which are available. You can go down there, and there are n number of people who are ready to help you down clear your queries. And not just that, Python, as it is an open source, you have a lot of new ideas that are being pitched in by developers to make Python better day by day. The next one is, as I mentioned earlier, Python provides libraries, but what makes Python really unique is that one of the major tasks in data science is to understand the data. And for this, Python provides various libraries like Matplotlib, Seaborn, Plotly to visualize our data. So this is another one of the reason why Python is specifically used for data science. Moving on to the next question, let's see some of the tools and libraries that you would be using when you're dealing with machine learning, deep learning, or data science projects over here. So first off, we'll talk about the IDEs. Some of the IDEs that are popular here are PyCharm, Jupyter, and Visual Studio Code. If you're someone who is using R, then you have RStudio. Some of the visualization tools that we have are Tableau, Matplotlib, Power BI, and Seaborn. Matplotlib and Seaborn are the dedicated ones to which use Python. And some of the libraries that you will be using on a regular basis are going to be NumPy, sklearn, Pandas, and Keras. So these are some of the very few libraries that I mentioned here. As you go deeper and deeper, you'd be finding yourself with the ocean of libraries and the APKs that you can download that with. All right then, guys, so moving on to the workflow. So what this workflow over here means is, let's say you have taken up a data science project, right? So how would you go around it? What are the different steps that you would take? So let's quickly see that up. So in general, the workflow of any data science task, like be it for machine learning, anything that relates to machine intelligence, right? So you have certain steps over here. First off is the collection of your data. You can collect your data, let it be on from web-based or some open source, you have Kaggle or something, data collection. Whatever data collection you do, we usually call that as a raw data. You cannot just directly use raw data, right? So you have to clean your raw data. So for that, we have data cleaning. And once you clean your data, you have to do some exploratory data analysis. In short, it is also referred to as EDA. So what happens in EDA, right? Well, if you want me to say it, EDA is basically like finding out errors, finding out if there are any missing values, finding out regularizing your the data so that it fits perfectly with the model. So this is what is exploratory data analysis. And once we're done with the EDA, we have model building. So what happens in model building? Whatever you have prehistoric data, right? So you whatever the data is that either be it in the tabular column or whatever it is, you try to put that in a mathematical equation, which is usually a function in programming. Okay, and then you have a model. And once you're done with your model, you try to perform cross validation to see if it's working well or not with the new data. And once you're done with your model building, you would definitely try to deploy the model. If you're someone who's working with Python, the two better ways to deploy the model is by using the fast API we have, then we have Django. So these are the different steps that a data scientist should take from the start to the end. To give you a better insight, I have also provided you over here. So first off, as I mentioned earlier, we'll have a raw data, and the raw data, I'll obviously try to perform exploratory data analysis, that is feature engineering. And once I'm done with the feature engineering, I'll try to build a mathematical model. I would use a machine. I would use basically over here mathematical equations to build a model. And sometimes what happens is you don't have to write a mathematical equation. We have various libraries like sklearn, keras. You just have to call that particular whatever model you want to use. Let's say you want to use linear regression, so you just have to call that up and you build your model. And once you're done with your model, make sure you perform evaluation on it, that is cross validation. And once you feel that you have an optimum accuracy or the parameters which you feel are right, all you can do is you can just deploy your model for the public use. So now that you have a brief gist about how this thing works, right? Like what are the steps that go in over here, and I mean to say, like what is data science in general? To to increase the curiosity and to learn more, what I've done over here is let me quickly give you a small demo how you can use Python to predict house prices in California. Although the code editor that you want to use is of your choice, but the code editor that I'm going to use over here is Google Colab. Okay, so Google Colab basically is a product by Google. Here it gives you a Jupyter notebook using which you can perform any data science functions. So let me quickly move to my Google Colab. Okay, so this is my Google Colab. You just click on the first link. You'll be presented with this. All you need to do is open a new Colab notebook. You can just give a name here, demo, and then make sure let me give you a quick walkthrough of this Google Colab. So if you have this runtime, change runtime type here. You can use GPU, TPU, and none. If you're dealing with computer vision or text-based stuff, then you definitely need to use GPU so that the computation is faster. Or else it's none. So let me just give here as GPU, although it's not needed. So if you want to run this, either you can run any of your cell or you can just hit connect here. Once you hit connect here, as you can see, this will take some time. Okay, let me zoom in a bit for you guys so that you can see it. Yeah, so you have to just write the code here. So let me first start off by having import warnings, because sometimes what happens is you'll get a lot of warnings, and if you want to ignore that, all you need to do is import warnings. Okay, you can run this by hitting shift enter, or all you can do is warnings dot filter warning. Here you have ignored. So this will ignore all your warnings. Okay, so there are various steps, as I mentioned earlier, when you try to perform or working with the data science projects. So first one is data collection, right? If you remember it right. So let me give text here, data collections. All right, guys. So the first step that we are gonna do over here is data collection. Okay, so what is this data collection, right? So as I mentioned earlier, data collection is basically we're trying to gather the data. And some of the ways that I can gather the data is by using, we have various ways. And one of them is by using, scraping the website. You can use various APIs for that. The other one is by getting it from Kaggle, or sometimes what happens is we have a built-in libraries. So let's kind of get the built-in libraries from sklearn. Okay, so for that we have to import a couple of libraries. So first off, we have the generic libraries. Okay, so this is import pandas as PD, import numpy as np, and then import matplotlib as plt. Okay, so these are the generic libraries. Then the library for importing the data. So for this I have from sklearn dot dataset. So this is the part here. Import fetch California house price. So we have fetch. Yep, we have this over here, California housing. So let's hit enter. So we have got our dataset, but let's now see. Let's now go visualize our dataset. Okay, but before that, we will create an instance of this data is equal to fetch California housing, and this is basically a function, and we'll call this. You'll see here that it's downloading this from this particular source, right? So once the downloading part is done, we can now visualize the data. Okay, so if you remember, right, I told you about independent and dependent variable. So let's now see the dependent and independent variable. So let me have this data. So as you can see here, this is how it looks. Alright guys, so as you can see here, we have a data in this format, but we are not getting much of it over here, right? So let me do one thing. Let me put this in a tabular format. So for you to do this in a tabular format, I'm going to use data frames. Okay, so let's say df as a data frame here. Df is equal to, if you remember, we have imported pandas, right? So that is pd dot data frame. All you need to do is have this data dot data. This is nothing but data present in this data over here. Okay, so if you want to see how data dot data looks like, let me add it here. So it's the same thing, it's just an array. All right, so apart from this, I also need to have columns, right? Name of the columns, or else it just won't look that good. If you want me to execute this without a column name, let me show you that as well. So you'll see here that we have columns, but we don't have any names over here. So in order to fix this up, it's pretty simple. So we have this parameter called as columns, and then all we need to do is data dot feature names. And now if I execute this, you'll see here that we have the various features. That's median income, house, average bedroom, population, and various other parameters. So all of these were the independent parameters, right? So these parameters are responsible for the house prices. Okay, so if you want to add in the independent parameters, or if you want to see how the independent parameter would look like, so for this we have something called as data dot target. So for this, what we can do is, for the same data frame, I'll add something called as target. Okay, so this is a new column that we are creating, and here we'll have data dot target. And if I execute this and show you df here, so now you'll see we have another column which says target. Okay, so this is a bit about collecting your data pre-processing. And now what I'm going to do is I'm going to show you how you can perform EDA. Okay, so EDA is basically like, we want to see how to understand what type of data we have. So for that, what I'm going to do is df, which is our data frame, not info. If I execute this function over here, it'll give me the total number of columns I have. Okay, and these are the different values that I have over here. So as you can see here, none of the values are missing. So we have 20,640, and none of the values are missing, but the data type of this is the float. Okay, so now what I want to do is, let's see which value that I can remove. So the value that I want to remove over here is going to be latitude and longitude. And the reason why I'm going to remove these two values, because either I have to perform feature engineering, like using latitude and longitude, find the location of this, which is easily possible, or I can just remove them up and I have various other features over here. So let me quickly remove latitude and longitude. Okay, so to do that, we have df dot drop. Okay, and here all you need to do is provide the name of the columns. So we have latitude and longitude. So let me just copy this up, paste it here, and let me give a semicolon here as well. Make sure you give df is equal to, or else you won't find any changes. So once you're done with this, okay, we have an error here. The reason is because I'm passing this through an array. Or the other way around is, we can just part labels here, and yeah, this should be fine. Oh yeah, one of the important reasons why we are getting this error is because we also are supposed to pass axis is equal to 1. And now let's see if this works. Yep, this works perfectly fine. And now if I put df, Okay, so as you can see here, now we no longer have latitude and longitude. We just have a target, and then we have these values. Okay, so this is a bit about how you can perform a very basic EDA on a very basic level, right? So this is one thing that we can do. So now what we'll do is we'll try to split this data between train test. Okay, this is basically done to see our model accuracy when we are trying to perform it. So if you want to perform train test split, we have some functions here. That is from sklearn dot model selection import train test split. So over here with this function, I can just perform train test split easily. So all you need to do is train test split. If you don't want to write the entire like the code, all you can do is write a question mark. You will get the description here, and all you gotta do is just copy this train test split over here, and you can just paste it in place of this, and then you can close this up. All right, so this will automatically perform train test split for us. So x and y here basically refers to the independent and dependent parameters. So let's add x over here. So this would be df. All right, so I need all the values, that is I need all the rows. So for all the rows is this, and then I need the rows from 0 to this one over here, -1. If you want to see how this would look like, let me just give you a brief description of this. So let me copy this and paste it here. This will give you all the rows except the target one. Okay guys, so as you can see here, we are getting this error, right? So the reason why we are getting this error is because of the data frame. So in order to avoid this, you have a couple of ways. All you need to do is df dot values, and then once you do it, you will see here we'll have all the values. So it will be from 1 2 3 4 5 6 columns we have. So this would be like basically 1 2 3 4 6. The target variable is been eliminated here. So I'll just copy this here and paste it over here. Okay, similarly for y, all we need to do is all the columns except the target one. So this would be just a single array. Okay, so let me copy this and paste it in place of y. Okay, this is the amount of split that I need. Usually we keep it as 30, which is 30%. Let me delete this cell for you guys. And now all we need to do is let me see if we have uppercase. Yep. The reason why I'm doing the uppercase is because this is just like our community standards. Okay, and let me hit enter. Okay, so now we have the values split between xtest, xtrain, and ytest and ytrain. All right guys, so now what we're going to do is we are going to add this to a model. So we won't be writing any model here. Instead of that, all we'll do is we'll try to apply this in a model. So the model that we are going to use over here is going to be let's say decision tree. So from sklearn dot tree import decision tree. Okay, and as this is a regression problem, so we are going to go with decision tree regressor. How do I know it's a regression problem? That's because the value is a numerical value, the output variables here. Okay, and let me hit enter here. And now it's pretty simple to perform decision tree. So first off, we'll create an object of this. Let me give it as dt, which stands for decision tree. And then I have an object of decision tree here, decision tree regressor. Okay, so if you can see here, we have various values here. This is criterion, this means basically based on mean square error, and splitter is the best, max depth none. So we can have this max depth parameter here. We can say this would actually prevent it by overfitting. So let's give here as 5. Okay, and then minimum sample split can be 2, minimum sample leave, we'll give that as 2 over here. we'll give it as 2. Minimum weight, that is by what value, if there's a change, we'll leave that for now. Maximum features, random state. Okay, let's add some random state. We'll say random state to be 20. You can give any random number there, and then yeah, I think this should be it for now. Let me execute this. Then we have dt dot fit transform. Okay, so this would basically train our model. So now we are supposed to pass value here, that is x test. It's going to be x train, and then we'll have y train. Okay, and I think this is it. And all we need to do is execute this value here. So we are done with the basically we are done here with the values. So let's now see the prediction. Okay, so dt dot, which is basically a model dot predict, and then now we're gonna predict the only like we have the test values, right? So we have the x test. So what I'm gonna do now is I'm just gonna pass x test, and then this would give me y pred, and I'm gonna see if my y pred and y test are almost similar or not. So over here I'm have y pred is equal to y predict dot x test. Okay, let's execute this. So now what we are going to do is let's see how well our model has performed with ypred and ytest. Okay, so let's quickly see that out. All right, so for this we have something called as okay, so for this what we're going to do is repeat. All right, so for this what we're going to do is we have this built-in library from sklearn.metrics import. So let's see what are the various libraries we have. We have accuracy score, which is basically for we use this for when you're dealing with classification task. Ours is not a classification task. So let's see what other things we have. We have classification report. Clusters goes basically for again, this is for the unsupervised learning. The confusion matrix goes for this thing. So here we have F1 score again, which goes in for let's say for classification task. Okay, so how can you evaluate this? So first off, we have a couple of parameters. We can use R-square method, or we can also use mean square error or mean absolute error. So let's go down to R-square. So that is R2 score. Let me execute this. So now we have R2 score. Here I'm going to pass the actual value, that is y true, that is going to be y test, and then the predicted value. Let me execute this. So it basically give me a number. So what does this number represents, right? So R2 score value varies from 1 to -1. If the value is somewhere near 0, it means that your model is like 50% accuracy, which means it is really bad. If the value is towards 1, right? So that is let's say anything above 50%, it means your model is performing well. Whereas if the model is moving towards -1, right, it means your model is underperforming, it's underfitting up. So this is what we have got here. We have got almost 60%, which is a good number for the model that we have done. In order to improve this model, we can change the hyperparameters and make it even better. Alright guys, with this we come to the end of this session. I hope you enjoyed and learned something new. If you're further interested in learning more about Python for data science, we have this free class by K21Academy. In order for you to register to this, all you need to do is go down to K21Academy.com/Python02. So let me quickly show you how you can register yourself for that. So for that, let me move to my web browser. So you have to do K21Academy.com/Python02. So with this free course link, right, it's absolutely free here. All you got to do is you have this, click on notify me, and all you need to do is add your number here. Like let's say my name is K21. Let me add up an email address and a phone number, which is an optional, and all you do is yes please. And once we have this, we'll definitely send you an email, and your interface would look something similar to this. Alright guys, if you have any further queries, please do mention them in the comment box below. Until next time, goodbye and take care.